Welcome, Algebra 2. This is section 5.1, Polynomial Functions. The essential question is, what are some distinguishing behaviors of polynomial functions? Let's begin. So this will be a bunch of vocabulary in this lesson, so just get ready to write. First thing is monomials. What is a monomial? You probably know this anyways, but a reminder, it's a real number, a variable, or a product of real number and variables. Basically, it's one term. You might have heard it that way. So these are all examples. X to the fourth. You can combine numbers and variables. You can combine multiple variables. There you go. A polynomial is one or more terms. So basically a bunch of monomials together. So 3x plus 2 could be polynomial. Just a monomial y to the 10th could be. Or a bunch of them slapped together. This has 4 terms. This is a polynomial. Other special cases, binomials have 2 terms. And trinomials have 3 terms. Other vocab words, a degree. Degree means the power of the variables in a term. So x to the 5th will be a 5th degree right here. This case, x squared and y to the 4th will be 6th degree. So it's the number of variables. It's not like, oh, there's one variable x. No, it's like the power of the variables all combined. Degree of a polynomial will be the greatest degree of all of the terms. So for 5x to the 4th plus x plus 1, the degree here is 4, this is a 1, and this is a 0 degree. So this will be a 4th degree because 4 is the highest. In this case, x is 1 degree and 1 is a 0 degree. The highest degree is 1, so it will be 1st degree. 5 times x to the 4th, well, it's a 4, and that's the highest. So this, again, will be a 4th degree. So that's how you find out what a degree is. And that'll be important information. Standard form of polynomial functions. This is a big description of it. The basic idea is that put them in the order so that the highest degree is first, all the way to the lowest. So you go highest degree, and you go all the way down in order to the lowest degree. So you're just rearranging them. So in this case, 4x cubed plus 3x squared plus 5x minus 2. You're going by degree. This is degree 3, 2, 1, and 0. It's not the coefficients, the 4, 3, 5, and 2. Those don't matter. It's the degree of each term. Ways to classify polynomials. This is a good chart for this. If you're talking something that's degree 0, what do we call this? We call this a constant because it's just some number. And so there's one term in this case, and since there's only one term, it's a monomial. When it's I think the big part's not really this part right here. It's this stuff right here. So if a degree is 1, we usually call it just a linear because it just has the just x parts, and if you graphed it, it'd be like a linear function. A degree of 2 is called a quadratic. A degree of 3 is called a cubic. And beyond that, we're just going to start calling things 4th degree and 5th degree and 6th, 7th, 8th, 9th, and 10th degree. So that's the way we classify polynomials. What does a polynomial function look like? So function, and this is function notation. You've seen this a few times off and on. So f of x, which is the same thing as like y, equals 2x squared plus 5x minus 6, and all these 3 functions. These are different types of functions, and notice they all have different shapes. This is a parabola, this is a cubic or an exponential. This is a cubic function right here, and this is a different shape right here. So they're all different types of shapes, right? Well, we have different behaviors of polynomial functions, and there's 2 words I want you to understand here. First thing is the turning points. Turning points are where the graph turns up or down. So, and we're talking about going from the left to the right. So if I'm going down at this part right here. You're going down, 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 and then at this point, you start going up. So the turning point happens right here. And in this case, if you're going from left to right, you start going up. And then once you hit this point, you start going down. And when you hit this point, you start going back up again. So these 2 points right here are the turning points. And in this case, you start going down, and then you hit this point down here, you start going up. Then at this peak here, you start going down again. And at this peak, you start going up. So in this case, we have 3 turning points. So, and one thing you want to know is the maximum number of turning points is 1 less than the degree. So this case, this function was, the degree of this function was 2 because it was f of x at 2x squared. And this degree was 3, and this degree was 4. Notice how many turning points do we have here? We have 1 turning point here. In this case, we have 2 turning points. In this case, we have 3 turning points. So the maximum number is 1 less than the degree. Next part. So the other vocab words I want you to understand is end behavior. And what's end behavior? It's the direction of the graph at the two ends. So the end behavior on this one is up on the left side and up on the right side. In this case, it is down on the left side and up on the right side. And in this case, they're both up again. So end behavior is just the way the graph goes at the two ends, in the negative side and the positive side. Which direction is it going? Usually going up forever or going down forever. And so we can determine the end behaviors just from the equation here, just looking at the expression of the function without actually graphing it. And the way you do that is you follow this matrix right here. So you have to look at the leading term. The leading term is the highest degree term. So in this case, and the formula says ax to the n. So in the case of our three functions, that's the leading term, this is the leading term, and this is the leading term. And you got to know what your a is, your coefficient. So your a in this case is 2. Your a in this case, since there's no coefficients, 1. And the a in this case is again 1. So you need to know what the leading coefficient is, and you need to know what the degree is, if the degree is even or if it's odd. In this case, the degree is 2, which is going to be even. The degree in this case is 3, which is going to be odd. And the degree in this case is 4, which is also even. When you know that information, you know what the end behavior is. So in this case, where a is 2, so a is not equal to 0. A is positive, which is positive 2, and it's even. It's going to be up and up, which is what we saw in that last graph. This was up and up. In this case here, a is positive, but it's odd, so it's going to be down and up. So down on the left, up on the right, and which was the case we saw here. It's down on the left and up on the right. For the last one, again, we're even. A is positive, and it's an even degree, so it's going to be up and up. And that's what we saw with the picture of the graph, up and up. So you follow that chart, you don't have to graph, and you can classify the end behavior. So let's talk some examples. Pause the video. All right, you want to write these in standard form, classified by degree and number of terms. So standard form means I got to put the highest degree to lowest degree. And I'm going to count this. This is degree 1, this is degree 2, and this is 0. So reordering that, it's going to be 9x squared plus 3x plus 5. Classify this by degree. Well, the degree of this is the highest term, which is 2. So we're going to call this is degree 2. And the number of terms. And there's 3 terms here. So this is according to that chart from way back here. And I said this stuff doesn't matter. Oh, nope. According from our vocab words, we have 3 terms here. So it's called a trinomial. So this will be a second degree trinomial. So I'll call this second degree trinomial. Or we can also call this a quadratic trinomial. Alright, next example. Rearrange this. This is a degree of, well, first I want to combine like terms. So that negative 6x squared and 10x squared actually combines to 4x squared. So we can ignore those now. Now we got a highest degree. That's degree 1. This is a degree of 2. This is a degree of 4. And this is a degree of 0. So rearranging that, it's x to the 4th power plus 4x squared plus 4x minus 12. This is a degree of 4. So this is going to be a 4th degree. And then there's 4 terms here. So it's not a trinomial. We'll just call this 4th degree. That's all I want you to write. Alright, and pause the video. What is the end behavior and the maximum number of turning points? These are the two. So without graphing these functions, we can figure that out. Well, to figure out end behavior here, we have to go back to that matrix. And we need to know that my a is positive or negative. So your a, your coefficient to the highest degree term here, a is positive, and you got to know the degree. The degree is 3, so the degree is odd. When you have a positive a and an odd degree, so positive and odd, you go down and up. So the end behavior is down up. And the maximum number of turning points. Well, the maximum number of turning points is the degree minus 1. So this can be 3 minus 1. So I'm going to say my turning points, maximum number is 2. Next one. Alright, so we have our a in this case. This is our highest degree term. So your a is going to be a negative number because it's negative 2. And the degree is going to be even because it's 4. So if you have an a is negative and your degree is 4, a is negative and it's even, it's going to be down and down. So my end behavior is down and down. And maximum number of turning points, since that's a degree of 4, turning points are going to be 3. All right, that's it.